We now embark on the fifth of our series of trickier simultaneous equations, and the equations are xy plus x plus y equals -5, yz plus y plus z equals 7, and zx plus z plus x is -3. Okay, now the ruse de guerre that we're going to use here is to replace x by a, where a is x plus 1, and likewise b, where b is y plus 1, and c is z plus 1. In other words, x is equal to a minus 1, y is equal to b minus 1, and z is equal to c minus 1. Now, when you substitute into the original equations, first of all into the equation 1, we'll get a minus 1 times b minus 1 plus a minus 1 plus b minus 1 is -5. When you multiply out the brackets, you get ab minus a minus b plus 1, and the remainder of it is plus a minus b plus 1 plus b minus 1. I'll read that line again. ab minus a minus b plus 1 plus a minus 1 plus b minus 1 equals -5, which simplifies very conveniently down to ab equals -4. Now, similarly, by substituting into the equations 2 and 3 in the same sort of way, you will quite easily, in the same manner, find that b times c is 8 and ca is -2. Now, from these latest results, you divide ab by bc, that is -4 over 8, and so the b's cancelling out means that a over c is -1/2. But we also have c times a, or a times c if you prefer, is equal to -2. And multiplying those two expressions together will eliminate the c. So here we have a over c times c over a equals 1, which means that a squared is 1, so a is equal to 1, or it's equal to -1. And then going back to the previous expressions in boxes, when a is 1, you can see that b is -4 and c is -2. And if a is -1, then b is +4 and c is +2. So the solution sets for a, b, c are 1 minus 4 -2 and -1 4 2. That's for a, b, and c. For x, y, and z, you have to take 1 off each of those, so because of our original substitution. So the final solution sets for x, y, and z are 0, -5, -3, and -2, 3, and 1. And that winds things up very nicely. Thank you for listening.